Good morning, Grid Connections listeners. I'm really excited to be sharing this episode with you today. I'm joined by two different representatives from XCharge North America. I know a really common theme we have on our episode is talking about charging infrastructure. And so I think it'd be great to have two representatives from the space who can talk to us about all the different intricacies and different challenges, along with, most importantly, the success they're seeing in this space. So today I'm joined by Andrew Kelley, the Director of Energy Solutions at XCharge North America, as well as Lou Cox. He's the Senior Director of Business Development at XCharge North America. Thank you, gentlemen, both for joining me today, and would just really love to kind of hear a little bit more for our listeners, intros of what you do and XCharge in general.
Sure. Thanks, Chase. We really appreciate you taking the time to chat with us a little bit. Guess I'll kick things off. Like you mentioned, my name's Lou Cox. I am the Senior Director of Biz Development here for XCharge, and my oversight is anything into some of our client solutions, helping people understand our hardware and the way to implement it, as well as, helping transact not only here in North America, but in some of the other spaces that XCharge operates globally.
All right. Thanks, Lou. So I'm Andrew Kelley, the Director of Energy Solutions. Joined XCharge this year, and my role, my focus here is I work very closely with our grid operator, our utility partners on the operations side, ensuring that our equipment is usable, acceptable in all different kinds of use cases, is accepted in various different kinds of subsidy programs, rebate programs, things like that. And then on the business development side, I'm seeking and looking for partnerships with those same kind of customers, grid operators, utility companies, developers who focus on the distributed energy space. I come from the renewable energy industry, so taking some of those perspectives into EV charging is something we're working on. The top line philosophy we have is, we're really a partner of, and we are in support of all the things that the grid needs to do to operate effectively in the future. Electrification is coming, and that's our goal here, is to work with the operators of the grid, make sure everything happens as smoothly and as efficiently as possible.
And I think that's exactly what our listeners like to hear. And thank you both. I guess I had to do a little bit of research in preparation of this. I'd come across XCharge a few times, but I think real quickly, can either you or both of you just kind of go over how XCharge kind of has come to the North American market, some of the ways that maybe that the company is approaching it differently, and just maybe the overall mindset of what makes XCharge different from others in the space right now.
Sure. Happy to kind of take that one up first and then kick it over to Andrew. So XCharge Group is a much larger entity than North America is at this moment. So at the group level, we currently operate in 22 different countries. We've deployed more than 40,000 pieces of hardware globally. We are top 2 in market share for DC fast charging manufacturing in Europe. And then we brought the first bi-directional battery integrated direct current fast charger to market as well last year. One of the things that really sets us apart is not only our, juggernaut status and how many things we've manufactured and deployed globally, but in the way that we kind of create our charging solutions to be very solution specific based on the use case, based on the available power, and what led to the launch of XCharge in North America is that, we're based in Hamburg, Germany, and we've had great success in Europe with some of the largest operators in the world, some of the largest power companies like NLX, EDP, and Vattenfall, which we work with, at significant scale globally. We realized that North America has always been about 5 or 6 years behind Europe from an infrastructure perspective. So transitioning some of the world's best equipment to North America is just a matter of education and a matter of working with your customers and end clients to really find the right utilization and the right use case to deploy the technology we've already kind of perfected. So for us in North America, it's just a matter of getting the gospel out there, right? Preaching how to build this stuff in a way that's scalable, sustainable, and does actually present an ROI that you can get to inside of a decade. And I was really excited to find the opportunity to work with XCharge and get that done here in North America.
No, that's great. I appreciate that overview. When you talk about some of the differences between kind of starting in Europe and maybe some of the lag that you're seeing here, that 5 to 6 years you talk about between here and North America, can you give a couple examples of what are some of the things that you're still seeing as maybe misinformation is the wrong word, but just a lot of maybe inaccurate assumptions that people are kind of thinking about when they hear or think about installing charging here in North America, at least.
Yeah, Andrew,
Yeah.
you want to take that one?
Yeah, I'll jump in with a couple of examples. I think the first most obvious example is that um, if I think a lot of folks think at a individual or micro level and all the way to the other end of the spectrum at the macro level at a country or perhaps a state level as to how do we deploy this infrastructure on the micro level. What I see a lot of folks saying, or whether it's through different media outlets in face-to-face conversations, and comment sections on some of these articles.
For sure.
A message that comes up time and time again is folks tend to be scared about or have some either combination of range anxiety and anxiety about where and when they can charge their vehicles as an individual users on things like road trips on a day-to-day basis. They're scared about the distribution of the system of the equipment, and then in deploying it, there's concerns that they actually building out of the infrastructure. So part one is they're scared to to kind of convert to electric as a whole. There's some fear there. And then on the development side, on the individual level, there's fear that it's going to be overly expensive, difficult to do, and the local, whether it's a utility company or power authority, the local provider isn't going to be able to support the transition in that specific area for everybody that needs it. And then on the macro level, a lot of folks are also saying, well, there's no way we can get 285 million or 300 million drivers in the next 3 years to transition fully. We don't have the capacity on the grid. We don't have the available resources to do so. This is a big task. So I think folks are really nervous. There's a lot of stress about both ends of the spectrum, but we have solutions, pretty simple solutions, to be honest, for both everything on the micro level, the macro level, and kind of everything in between. I can go through more of that as we go through our conversation today, but I think those fears are certainly prevalent, and those fears trickle at a sort of, or expand out to even on the commercial customers, to grid operators. There's certainly this fear about this kind of equipment as being overly burdensome, difficult, and expensive to deploy and maintain. So I think those are some of the challenges we're running up.
Yeah, just a few. Nothing serious, right?
No big deal.
Yeah. Well, I think one of the other things, maybe to take a step back, just for anyone listening who isn't familiar with XCharge, can you kind of give us just a quick overview? Because as far as I know, XCharge only has a majority of the focus is in DC fast charging. I believe there maybe has been some AC in the past, but just kind of give a quick product overview real briefly, just so for those who might be out driving, maybe they've plugged into an XCharge charger and just didn't realize that's what it was.
It's very possible. Right now, XCharge does power quite a bit of infrastructure, not only around North America, but globally. Our product suite, we make three major products we sell here in North America. Globally, we do offer some other things based on use case, including level 2 or AC charging products, and the C2 is what we call it. We don't actively sell that here in North America. We're focused primarily on DC fast charging. But what differentiates XCharge from some of our competitors or some of the things that you've seen out there in the world is that our solutions are, like I talked about, very site specific. Whereas if you happen to be a commercial developer or somebody who owns a piece of commercial property and you said, hey, I would like to get in on this Charge EV game, right? I would like to be able to turn my property into the refueling station of the future, if you will. Now, what you would typically do is you would contact someone, call it a charge point or any other EVSE manufacturer, and you would say, I would like to order 2 DC fast chargers. And they say, that's great. It'll cost you, call it $150,000. And then the install might be another $100,000. And then you've got 18 months in lead time from the utility in order to get that done because you don't have 480 power coming to your site, right? You've got 208. Well, we manufacture a 208 solution as well as the 480 solution, so we get a little bit of the gambit of everybody. If you are that commercial property owner and you have a couple hundred amps of 208, we have a product called the C6AM, which is up to 200 kilowatts. This is something that you can install on 208 volt infrastructure without any transformers, without any supporting equipment. This is not, a power cabinet and dispenser setup. It's an all-in-one contained unit that you can sit on a little concrete pad with minimal construction costs, and it charges charges two vehicles simultaneously. That is our most popular product. We've deployed that one, more than 10,000 times globally, and that is something that uses what's called dynamic load balancing to determine the state of charge between the two vehicles and then prioritize the one with a lower state of charge so that everybody gets what they need and can get back on the road. Now, the revolutionary thing about that charger, as I talked about, is it's a single point of connection, meaning that all you need is a little bit of conduit directly to the house panel on that property we're talking about, which doesn't require any significant infrastructure upgrades. That's the most popular way that people who are getting into the game today and aren't looking to build out these giant hubs of 20 or 30 stalls, that's the way you would do it. Whereas if you do want to get into the 20 or 30 stall game, we offer solutions that have battery integrated solutions. We offer 420 kilowatt super high output chargers as well, that can charge up to 4 vehicles at a time. It really just depends on, the customer, the property, what's available there. But at XCharge, we typically, like we talk about, we're solutions oriented. So you just say, hey, I have a property with X amount of power available, and we definitely make a solution to get you energized today versus 18 months from now.
Yeah, I really appreciate that context. I think when you're talking about these sorts of solutions, and apologies if you can hear my dogs in the background right now.
No problem.
But what do you see as, with this kind of focus, like, do you see a lot of, it sounds like it's usually kind of maybe a company that's trying to offer charging for its workers as a kind of maybe like a benefit, or are you kind of see a pretty broad spectrum of customers? The reason I ask is on the most recent episode, we had JT from Franklin's Charging, and he actually has 2 charging locations in Arkansas, where he has, I think, one that he's essentially set up to kind of be like modern convenience stores. And just with the kind of the examples you were talking about, it was interesting talking to him and kind of like some of the challenges he's obviously had to go through with setting this up and getting this going. But yeah, I'd just be curious if you can share any more maybe about if there's any kind of trends you're seeing with the people that are currently kind of looking at installing these, or has it been a pretty wide range of interest?
Yeah, I think there's definitely a trend. So my background, I come from the EPC world, which is engineering, procurement, and construction, where, my prior firm, we were doing the design, the engineering, the permitting, obviously the procurement and construction of DC fast charging equipment for all the largest operators currently in North America. All the big names, which I won't list here. You can think of them. Their logos are blue or green or red or yellow or whoever. We were doing work to help install their solutions. And very often we would get on site and realize that it just wasn't feasible in any kind of reasonable amount of time frame for any reasonable amount of money. So what we get now, and sort of what led to me joining XCharge, is we see people who all think it's a good idea to put DC fast chargers at their commercial properties, at their shopping centers, at their business centers, at their, park and ride parking lots, but they don't quite understand power, right? So when they get on site and they say, okay, these 6 stalls, they look good. It's in the open. There's nothing around it. Let's turn those into charging locations. And they go and get a quote, and they realize that getting 480 power there will be north of $500,000 just to get started, right? And then people really, for some reason in North America, people are very fixated on return on investment. For an institutional investor or somebody who's a developer, they're used to ROIs of 3-4 years before they get their money back and start seeing profit. In DC fast charging, it hasn't been that way. It's typically been north of 7 or 8 or sometimes 12 years before you see a return on that first dollar you spent to build out this fast charging network, because EV adoption isn't where it needs to be. In the most aggressive of cases, even including California, you're talking sub 10% of all vehicles, right? But once that number gets to 30 or 40%, it's a no-brainer and you make your money back extremely quickly. But it's a chicken or an egg kind of situation, right? How do you get to 30 or 40%, global adoption? You build the infrastructure. So those pioneers that are going out now and doing the research to figure out how to get it done are running into the power constraints, right? Are running into the grid issues that everybody talks about and that rhetoric, kind of that Andrew was alluding to earlier. And what they do is they go and get these quotes. Like I said, they're quoted a huge number. They look at the ROI and say, this is a bad business, right? And just objectively make that decision and kind of walk away from it. And we run into a lot of those folks who, after running into our solutions and finding out you can do this on 208, or you can do it on limited 480 with a battery as an integrated solution, they start to come back to that table and start to really rethink what this looks like. And they reset their expectations of, okay, maybe I won't make my money back in 3 years, right? But, I can dramatically increase it from 12 12 down to 4 or 5 if I use some of these XCharge solutions, if I think about it, in a different way than has been historically thought about in North America. In Europe, most of the charging is handled by the utility companies. The overwhelming majority of the charging deployments are managed and handled by utility companies or very large energy services firms. Here in North America, it's almost like outside of Tesla, everybody does it as a business, right, to get a return on it. And it's very difficult to do that if you don't also control the power like you do in Europe. So you're going to need that interim solution that provides you with opportunities to deploy infrastructure now for dramatically less than the way that most people have been thinking about it here in North America.
Gotcha. No, I mean, that totally makes sense. And it's funny you mentioned the focus on ROI, because that doesn't surprise me at all,
Right.
for better or for worse, unfortunately. But I guess going back to JT's example of how he was kind of talking about the big thing, because you're right, there he saw the value in it, but it is a longer kind of time horizon. His focus was like, okay, I'm going to look at these sites and have multiple cash flows and have other things that can make me money
Right.
more kind of upfront and quickly, and then that'll be a longer term thing, which totally makes sense. One thing though that kind of surprised me but totally made sense was he was talking about with some of the vendors he was working with for the charging uh, pedestals. Essentially, he had the option to lease them, and that's what he thought
Sure.
was a really attractive option. It kind of gave him some form of future proofing. At least that's what it sounded like in the agreement. Is that something that XCharge currently offers, or is that something kind of out of your scope right now?
Yeah, it is. For us, it's just about getting the hardware in people's hands. That's one of the benefits of being a larger organization globally, because we have, the ability to provide these flexible solutions. We really have three ways of transacting currently. If you've decided you have the right property, you would bring it to us. You would say, I would like, 2 to 4 stalls of DC fast charging. How do I get that done? Either Andrew or I or some of the other folks on the business development team would sit down over a call with you and review what you have, review what you've looked into, what's important to you on your wish list. And then we decide, okay, 2 C6s make sense here. How would you like to pay for that? That would be, X amount of dollars. Do you want to pay up front for that? And they're saying, okay, well, I'm pretty capital constrained. So, what other options do you have? We do provide leasing, right? We'll come and bring the infrastructure. We'll bring the improvements. We'll handle the utility portion of it and get you energized. And then you kind of pay per kilowatt hour that's distributed. And then you take a margin in the middle. Or we provide what's called charging as a service. Whereas if you're a fleet customer and you have an immediate need, say you're an Amazon last mile logistics company, relatively small, but you've just started up in Wyoming and you need to get your new Rivian delivery vans powered up so that you can take them out to your customers. So at your depot, we would come and evaluate where we would put the chargers and how many vehicles you've got. And then we'll come and just bring the infrastructure. And then we work out a per month payment that you would make on the infrastructure for a period of time. And at the end of that contract, if you choose to buy the infrastructure and just own it outright, we'll give you a buyout number at the end of that. And that's very simple. Now, if you're a public commercial parking lot, say you're a mall or something, and you want to just provide it as an amenity to your customers, you can bring us the property, and then in most cases we'll lease that property from you, pay you a fixed amount per month per stall, and then we will bring all the infrastructure and you still get to provide that to your customers as well, right? So if you do have the right property and you're forward thinking about how to charge vehicles in the future, there is always a way to work with XCharge.
Gotcha. No, that's interesting. That's great to hear, because I think one of the areas where there's a lot of opportunity is definitely in the fleet charging, and I think that's something I'd be kind of curious to talk with you a little bit more about here in a second. But
Sure.
not to go down too much of a rabbit hole, since you brought up your previous background and you were just talking about like installing charging in large parking lots. One thing that I have always been a big proponent of, and I've just quite not understood why it hasn't taken off more, is um, installing essentially charging arrays in parking lots with having kind of the covered solar, and then doing that in conjunction with charging systems. I realize it's probably not going to be a one-to-one, and it is more expensive to usually get those installed in the actual infrastructure for the kind of the solar awnings and the canopies in these parking garage
Oh
or
yeah.
parking structures. But it's still, to me, it's just fascinating that that hasn't taken off more, just because of how close it is to the actual load that's being consumed versus like putting a solar installation further out. I realize there are extra costs with that and some savings here and there, but it just seems like that is such a great opportunity to have the energy being generated going right or converted right into the cars, and or the actual main thing using so much of this energy. Is that, I just out of curiosity, if you can share it, is that something you're seeing more interest in, or is that still just kind of too cost prohibitive?
Well, Andrew happens to be the
Yeah,
expert in that
I'll
territory.
I'll jump right in here. All right, so great tee off here. Appreciate that. This is something near and dear to my heart as well. Um, so when it comes to photovoltaic, we'll call it integrated DC fast charger stations, any kind of commercial properties with photovoltaic infrastructure. There's a few use cases and a few customer examples where it's a no-brainer or it's a really smart idea. Generally speaking, of course, there's going to be nuances here and there, but generally speaking, it's a very good idea in a certain number of applications. The typical applications where I think this makes a lot of sense, where you'll see it makes a lot of sense, and sense in this case means there's enough power to make an impact on the either charging or the energy consumed on site to make an actual measurable impact on what you use, what you need on site. That's the way it makes sense in one sense, and then financially it makes sense in another way. And there's a number of ways for the financials to make sense. Generally speaking, when you're looking at certain types of parking lots, if the parking lot is perhaps owned by a single business, like it's a business center, or perhaps it's part of a school or a fleet owned by a single entity and owned and operated by a single entity for that purpose, like a high school parking lot, absolutely a solar canopy with their EV charging infrastructure is a great kind of symbiotic project to do it. It's a great option. When you have a kind of on the flip side, a shopping center owned perhaps by multiple state or leased by various property, various different users. Perhaps there's various businesses, might be owned at the high level by a single operator or a single commercial property owner, but each business is separately owned. Perhaps there's a bunch of franchises on there. The infrastructure has to be tied to something kind of commonly used or owned by the owner. It's a lot more challenging to, if you want to call it, divide up the value of that solar and charging infrastructure and assign that to 25 different businesses.
Right.
So that's a big challenge. Now, it doesn't mean there aren't examples where that does work, but it's a little more complicated. You see less of that happening when you have it at a school or a business where the business owns the entire parking lot, the entire building, or they're leasing it for, say, 25 years, a long-term lease. That kind of investment makes a lot more sense for that business. They're getting that return. The economics of photovoltaics differ from state to state, so that does have a factor in it as well. But I think just at a high level, there's a really good symbiotic relationship between the two. You generate power on site. If you can divert as much of that power to the vehicles that need it when they need it during the daytime, that's one of the most cost-effective ways to do it, especially over the long term. And just a typical lifespan, to give you an idea, if you invest in a solar photovoltaic array, the expectation is for that equipment to be up there to be productive for 20 plus years. So theoretically, that could be more than one DC fast charger, generation. One or two installations of DC fast charging equipment could be connected to that solar system. So it's a case by case basis. You want to pick, the right locations for it, but you're absolutely right. There's a good relationship between the two. We're testing it ourselves. We're excited to see how it works. Again, I think the other factor is available space. Do you have enough parking lot space to produce enough power for it to be worth it?
Fair.
The actual construction of those shade structures or carports, there's a cost associated with that. You have to get to a certain production level to offset or to make that kind of investment worth it. But should you have rooftop space available, that's a good solution too. It doesn't have the same optics as a nice, beautiful shade array in your carport, but it might be a more cost-effective way of still getting that benefit, especially when you have maybe a more constrained parking lot or shade threats, or you don't have the right kind of layout in the parking lot, but you still have a great rooftop. Maybe you have a big building. There's different ways to do it. So, your head's in the right place.
Yeah, and I
just to
appreciate
add
that.
into that.
Oh, go for it.
Yeah,
Yeah,
so
yeah.
to add a little color, when he's talking about the amount of space you need, just using round numbers, say take a typical Electrify America install, for example, where you've got 4 stalls of 150 to 350 kilowatt DC fast chargers. Even just to get a 60 kilowatt solar system in place, right, which is not a ton of power, which wouldn't, on its own power even half of one of those units. You're talking, almost 300 square meters of space to get that done. By the time you do the conversions and get that run to some batteries, 4,000 square feet worth of space of
Right.
solar system in order to power half of one of those units, right? So the only way that solar really makes a ton of sense in a commercial ultra high power charging circumstance would be to use batteries as like an arbitrage device in between, the solar to the DC battery, or converting that from from AC to DC through the battery and the charger itself, so that it's more efficient. And that's one of the things that our Net Zero series, the NZS, the battery integrated charger that we manufacture, does do. It is fully compatible with a 60 kilowatt solar system, but I think people underestimate the amount of surface area
For
required to get a
sure.
60 kilowatt solar system up and running. And even then, we're talking, 1/5 of the power demanded at any one time is going to be generated through solar, and the rest of it is going to come from the grid anyway. So you're going to have to store that somewhere and then utilize it all at once.
Yeah, and I agree. And I think I don't know. I always realize this is a little bit of a pipe dream. I was and this admittedly was a decade ago, maybe even longer now, but I actually was working with a lot of commercial solar companies. And back then, if you're like talking about something like, oh, it's $4 to $3 a watt, that was like
Yeah.
really cheap. And so to see how much it's come down, um, I can almost like it's got to pencil out. And then even just recently, and I realize this is definitely on the kind of farther side of the what makes sense for this kind of use case spectrum. I was just down in Arizona over Thanksgiving, and everywhere you go, there are so many carports that are
Yeah.
installed over the parking lots in general,
Sure.
just to give the cars shade.
Sure.
And you see this in Southern California, of course, too. And I felt a little better because when I was down most recently, I did driving around see a couple of these that were being installed that did have solar on them. But and you're totally right. I can't argue with the physics of it as far as like surface area to what one of these charges uses at one time. Obviously, the most efficient use of that is going to be a battery versus the solar. But I there's still part of me that just like this has got to work somehow. But
Right.
I think that's a really interesting point that you bring up around, and totally makes sense. Where it's a pretty clear answer when you have one entity that owns the building and owns the parking lot. The instant you start getting into things where it's multiple entities or
Right.
the main entity is leasing the building, yeah, I can
Third-party
see why
charge
that.
point operator in the parking lot, right? That only has consent to operate the stalls. Typically, when
Right.
charging companies would approach these large centers, they're saying we're minimally invasive, just these six
Yeah.
stalls and the power cabinets, right? So when you start a serious construction project and put in a carport that didn't exist beforehand, that's 4,000 square feet, right? And then you're
Right.
talking about the integration of the batteries, and based on the jurisdiction and the fire code, the batteries can't be directly next to the vehicles that are charging. So that's another portion of the property you've got to take up with an entitlement. It's not always as clean and easy as people would like it to be. We wish it
Right.
was. We're actually trialing a project now in Northern California where we are using the roof of a convenience store for some solar, as well as using the parking lot for DC fast charging, and then we're using our battery system to integrate in between that and truly be
Very
off
cool.
grid. Our Net Zero series does form a grid with its capabilities on the battery. So the battery itself, like I mentioned, is bidirectional and can back up the building, can take in the solar input, doesn't actually need a grid connection at all to still provide a 200 kilowatt output charge. That's really cool technology. And where it makes sense is in these places where they are very grid constrained, and places like using Vegas as an example. I just don't think you'll see a whole lot of solar battery DC fast charging integration when places in Vegas, they typically have more solar energy than the rest of the world,
Right.
in most
Right.
cases. So they're not hammering for you to install more of it so that you can peak shave. They'll just give you the energy, and it's quicker and more efficient to take it from the utility directly there.
Interesting. And now, I guess just a clarification for people listening and even myself, when you say these systems have batteries, is the battery a separate unit or is it part of the chargers? Or in some of these, do you do both?
Good question. It's built into the charger for our Net Zero series. All of
Gotcha.
our units are capable of functioning with batteries, and all of them are bidirectional. But our Net Zero series is an all-in-one unit with a single point of connection to the battery. And what's really cool about that is to install say our Net Zero series Gen 3 is a 300 output charger, simultaneous charging between the two ports. To get a 300 kilowatt output charger, you typically need between 4 and 500 amps of 483 phase. Just to put that in context, no property has an open 500 amps now. Maybe an airport, right, or some large distribution hub.
A manufacturing facility, yeah,
exactly.
Or something.
The parking lot of Avon's definitely doesn't have it, right? So in order to get that done, you would need a significant power upgrade. Whereas we can deliver that on as little as 80 amps of 483 phase because we use the battery on a much smaller grid connection, loads the battery up during off-peak times, which is also the cheapest time to buy energy, right? Between midnight and 6 a.m. So you've stored the battery full of energy during off-peak, and then during peak times, you're able to sell it to vehicles, for whatever the market rate of a per kilowatt hour charge is, as well as participate in some of the open markets, which we're doing currently in California, Texas, and New York, in these deregulated energy markets, which I'll kick over to Andrew to provide some more context. But say you buy the energy at a certain number, and then there's a demand event. We sign up for what's called demand response, where the utility says, oh, we're, at risk of a blackout or a brownout. What energy resources in that area do we have that we can pull from? Our Net Zero series chargers are registered as resources to do that, and the utility can take a couple of hundred, kilowatt hours, maybe a megawatt hour if we have several on site, and they'll buy that energy back from us, at a little more than we paid for it overnight to store it. And not only did we make money without having to charge any vehicles or really doing anything at all, but we were able to support the local grid and provide a service to the utility companies, and that's primarily some of the stuff that Andrew's working on. So I'll kick it over to him to provide some more context as to what that really looks like on the ground.
Yeah, thanks, Lou. Yeah, it's a really exciting area. I referenced a couple times about the anxiety around straining the grid. What can we do to make to deploy this equipment more efficiently, faster, more effectively? And I think this really gets to the heart of those topics. We have enough generation in the United States to convert every single driver to electric and still have 75% of our annual capacity available. So there is enough power generated today to make every vehicle in the country, and we're talking just regular everyday drivers to delivery vehicles, everything in between. So we can convert the entire driving community in the United States to electric pretty simply. We just have to, the demand and the supply, they're not always in sync with one another. So the battery component here is an essential, and literally an essential component, is an essential part of the equation, where you, as the DC fast charger owner or property owner, you get to start participating in managing these resources, and you get compensated for managing that. A couple of examples, Lou referenced a few, are you get to offset the cost of your energy that you pull from the grid or that you need to supply to the vehicle. So you get to offset some of those costs by choosing when in the day electricity is less expensive, and that also works throughout the year. That might fluctuate different times of year depending
helps
on
that ROI we were talking about.
Exactly.
Right?
So you can massage down that number. That also helps you with demand charges. We could probably spend a nice whole hour on various utility, just reading a utility bill together, but I'm not going to do that today. We could perhaps pencil some of those topics for another time. But the demand charge is something that all commercial property owners have to pay one way or the other, and it's calculated on their potential energy uses, regardless of their actual usage. So they may have a peak usage event certain days per month. Maybe they're a manufacturer, for example, and they have a manufacturing process that's very energy intensive, but it only happens, say, once a month. They're going to be charged an incredibly high demand charge to supply or potentially supply that building with enough energy. This kind of a product, when you add DC fast charging, you're going to spend a little bit more money on your utility bill. Your electric usage is going to go up because you're supplying quite a large amount of electricity to vehicles. We can help you manage those demand charges, which again are pretty significant. They could also be sometimes 4 or 5 times the cost of the energy you actually buy. So we can help you manage that demand charge by choosing when you charge and how you charge, how often and how long you charge your system. Charging up that battery helps you do that, helps you manage that. So we can manage that energy flow appropriately and as efficiently as possible. So minimize those charges. You can use the battery again to supply power to the vehicles, and it also works like any traditional backup power source too for your, to power your local loads. So if you have any loads you'd like to back up, you have that backup power available. And then in the bigger picture, if there are customers, ratepayers in the geographic area near you, regulated that need supply or need electricity, well, the traditional method is to divert energy available to those properties or turn on a power plant. Instead of turning on expensive power plants, the utilities are getting smart. Grid operators are smart, and they're able to find and use resources in that general area. Signal an event, tell you, hey, XCharge property A, we have a demand for your energy. We'd like to pay you this price. Do you accept? So you get to start participating in this automatically. Now we're going to set this up so this happens automatically for the property owner. You don't have to be an engaged energy trader or anything like that. But it's an exciting time, an exciting place for us to really work in tandem with the grid operators. So while this is a DC fast charger, while we're charging cars, you're also able to support your neighbors, support the communities around you, and help them with the energy that they need. So it's really a very holistic look at how we operate with the grid. A couple of examples, just to get kind of down to ground level, a couple of examples of ways you can monetize that is a demand response program is one of those. California, New York, New England, Texas, a variety of states also have a lot of other wholesale energy trading options. We can help you enroll in what's called a virtual power plant. We can show you how to do this yourselves if you don't want to go that route, but we want to make it as simple as possible. So you plug into the grid, you plug into these different revenue streams, you start supporting the grid. We've seen this to be significantly beneficial to the ROI on your project as well. And this could shave off, one or more years, certainly add thousands in annual revenue, and definitely increase that IRR quite significantly. So yeah, we're really excited that all these various operators are looking at the challenges of the grid holistically and seeing us as a participant rather than just a user. Or we're not just part of the demand equation. This was really the look here. So
yeah, I think that hits on like a lot of really interesting different topics actually, and kind of bringing all those together, but especially with demand charges. I think that's something that probably doesn't get the full understanding or kind of full appreciation for actually how important and how big of a deal that is for a lot of these operators and the sites that they're going into, and how much of a big cost that is sometimes to do these upgrades. But then working with someone who can kind of have that strategy of how to proactively mitigate it. And even especially in kind of like the case, like you're saying, like a manufacturing or larger site, you can actually then use this hardware and technology to kind of help bring those costs down and kind of look at it in a much more holistic and ideally help accelerate those savings, whether they're making money on the charging or not at that point. Right. Because it is shocking to me how expensive those demand charges can be for these companies. I think this is also an interesting thing because we talk about, to do all this, it requires software. And I would be really interested to hear kind of maybe some of the back end technology. Actually, there's two things real quickly. One, you said the battery is a part of the charger. What is the actual size of the battery in the charger?
Yeah.
It's a 233 kilowatt hours per battery pack. So you can design, our system is comprised of a single or dual battery configuration. So 233, 466.
Oh, wow. So almost either a quarter or almost a half megawatt hour of power just in the charger. Wow. That is actually, that's impressive. That's larger than I thought. Yeah. So that's awesome. That makes sense for those use cases. But then, I guess, going to the second part of that then would be, well, I guess one other question. So is there a limit in theory to like what size you could put these together? So like, can you do 4 of them and get close to like a megawatt hour, or can you let's say you are some like a aluminum smelter or something,
Sure.
and you want to get like 10 or 20 of these things to mitigate those demand charges. Is there a limit with XCharge's hardware?
Not on the hardware side. I want to point out, just to set some clear expectations, if any potential customers might be listening, or folks who know customers, the hardware operates independently of itself right now. We have software so you can control a whole station. You can organically and holistically, and those are kind of general terms, and I'll explain what they mean. Control your whole charging station. So you could have a view where you look at all of the chargers that might be, say, as you mentioned, 5 of these Net Zero series on a single site. You can control that with our backend software virtually or on site individually, but you can control the whole plant virtually. I do want to be careful to point out, though, that the systems aren't really digitally talking to each other in a significant way at this point. If there is interest in some, I would say, advanced communication between these devices, we'd want to evaluate what those needs are. If we can't do it with our existing software, where there are third parties that we can work with to coordinate, the usage of those assets. But generally speaking, for most applications, for most use cases, especially large commercial energy storage use cases, we can design we can tweak the software that we have right now to give you enough control to get maximum benefit out of it. But if they're expecting it to be as truly seamless as one megawatt hour battery, it'll behave slightly different. Like, you'll have to really think about it as 5 individual systems operating together. Just to be clear, you wouldn't want to connect these, or you wouldn't connect these all, kind of string them all together in one system to make one giant battery integrated DC fast charger system. But that doesn't mean you're still at a site where you have, we'll say, a megawatt hour or a megawatt of usage, or you might want to back up a megawatt load. You have the ability to actually get pretty close to that, pretty darn close to that. A little bit of planning, some participate, some management of the software, you'll be able to effectively manage your loads pretty well and still use a DC fast charger to your heart's content.
Yeah, and I appreciate that clarification, because realistically, that is a pretty extreme use case. Yeah, you would need a megawatt hour of power, just like, I'm going to use that right now. But that is, I mean, even when you're talking about like 233 kilowatt hours, like you were saying earlier, I think, and that's still, I mean, that's essentially like 2 Model S or pretty large battery packs, even a car, just right there at any time. So that totally makes sense. With I guess, just out of curiosity, are you able to share what kind of chemistry that those use? Is that like an LFP sort of?
It is LFP. Yep, you got it. Nailed it. Good guess. Yep, lithium ion LFP chemistry.
Gotcha.
Yep.
Okay.
The reason
that
we use
makes
the
a lot of sense.
LFP is it's much safer. From an installation, from public facing perspective,
Mhm.
we very much so use LFP to limit thermal runaway, right? So if you do have a bad cell, it doesn't, kind
Fair.
of spiral out of control and turn into a thermal event. That does happen with other kind of battery technologies, and it doesn't with ours, right? So that's something that we're very cognizant of, and I think in addition to it being, safer, they retain their usefulness over life, over the time of deployment much better. One of the use cases I was talking with a customer about the other day, and a lot of the things we hear from pushback on battery and charging is, oh, well, what happens in a power outage and I won't be able to charge my car? And I'm like, you are aware that in an outage you can't get gas either, right? Like, that's
right.
You will not be able to go to a gas station and swipe your card and start distributing gallons. The whole thing will be dark. So what we've done at one of our what we call our flagship locations is we're installing the Net Zero series, bidirectionally at a gas station, so that when there is a blackout, the only way people will be able to get gas is because of our DC fast charger on site, right? And that's kind of a fun little way to show the naysayers really what this means in practicality. It's grid forming up to 120 kilowatt, right? So that means that any load on that same circuit up to 120 kilowatt, which a gas station is far below, is going to be very reliable coming out of our units. And, that's the only way that any vehicle is getting recharged or refueled in a blackout, is through a battery integrated bidirectional solution.
And if it had solar, even better. No, I'm just messing. But
Yeah.
no,
Yep.
I totally
It's
get what you're
true.
saying. And the LFP makes sense just because there's really no concern about weight penalty at that point.
Right.
No, and I think that that's something we're seeing with a lot of grid tied batteries that makes sense. And I think you're totally right. That is a really common and interesting misperception, understandably, that a lot
Sure.
of people have about fuel pumps. Because I think I remember, what was it like? The reason they're called pump, I mean, technically they're still pumping fuel, yes, but it was like back in the 50s and maybe even as late as the 60s, like some of them
Yeah.
were even hand pump,
Yep.
especially I think for like the old diesel ones. And that's kind of how
Sure.
that name
Absolutely.
kind of came from that.
I
But
haven't seen one in a long time,
yeah,
and it's
yeah,
very
I don't think
unlikely
I've
we find
ever
it.
seen one. But that's, I believe, why the name has that. And like that would be like the only circumstance, and I doubt any of those are still around today that would work.
Right.
But
Maybe a
yeah,
movie.
you're
I've seen him in
totally
a
right.
movie, but
Yeah, in movies
Exactly.
maybe,
Yeah,
right? But everybody thinks it
a
just
very
makes
very old
sense.
movie. Right. Yeah, so no, this has been great, but I think we have kind of talked about a little bit, so I would be kind of interested in getting more of an overview of just what the software that XCharge has, and as a driver, or maybe just let's say a civilian or just a regular person might, how would they experience or see the software? Would they be in their car and they could see that there's, would they get live data from one of these chargers, maybe to say that it's available? Or just if you could just share kind of an overview
Yeah.
of
What the
what the software
experience is like.
does.
yeah.
Exactly.
Sure. So, I mean, there's a couple of different viewpoints you see depending on which side of the equation you're on. If you happen to be the site host or the property owner, you get an included dashboard. We don't charge for our software like a lot of other companies do. There's no subscription fee, no ongoing payment or anything like that. We feel that it's an integral part of just being able to operate the equipment, right? So we include it at sale, and that's for life, a license to use the software for life. If you're the site host, you get all the data that you want. If you're using the battery integrated solutions, you get 5 different energy management modes, and that goes from eco mode, meaning that you want to only charge the battery at the most efficient times overnight or in the wee early hours of the morning. You get max mode, which is make sure the battery is topped up all the time. You get a mix, something 50-50 in the middle. You get solar only and you get grid only, right? So you have the flexibility to determine what the input on your battery is going to be, which helps you dramatically change the ROI on how effective it is to charging vehicles. You can even limit the output current. If your battery is at 20% and you only want to charge cars at 150 kilowatt versus 300 kilowatt, right? Still a decent fast charge for folks, but if the battery is still recharging, you don't want to dump all of it, at that time into a vehicle. And another great thing about our units, which is, industry leading, is once our battery is empty, it's a direct pass through to our grid connection, which will still give you up to 120 kilowatt output charge. If you're a driver and you pull up to an XCharge station, it couldn't be easier to determine, what station you should plug into. We have 3 different battery indicator lights, from here's the state of charge of the battery itself, here's the state of charge of the vehicle that's currently plugged in at the right port and how fast they're charging, and then the left port's available where you could plug in, and here's how much energy is available for you, right? And you can make that decision on the fly through 3 different methods. Like I said, the indicator lights, there's a 33-inch LCD display that'll have vehicle and charger and battery information up front, and there's also a 13-inch display down below where you would select your connector that'll tell you very specific information. Once you plug in, here's how much energy we can give you for how long until that other car reaches full, and once that car is full, we'll redirect all of it back to you, and then you'll finish your charging session as well. So like I said, it definitely varies depending on which side of the fence you're on, being the site host or the user of the charging station. But we find it very important to be transparent with people about what is available, how quickly can you charge, and really which unit should you pick. If you pulled up to a unit that had a red battery indicator light, meaning it's currently recharging, you're not going to be that fast. Go 2 stalls over and you've got one that's full, that sort of thing.
Gotcha. No, that all makes sense, and that's really helpful. And it's always good to kind of see the balance between the software and then also the physical hardware that kind of simplifies sometimes for
Yes.
someone who might not know otherwise.
At a glance. Yep.
Yeah. With that and kind of what your team is kind of looking at and hearing, are there any interesting trends that you're kind of seeing as far as like the growth and kind of like where you see maybe the industry going over the next 5 years?
I think we've seen a whole lot of use cases, a whole lot of businesses come out and say, here's how we're going to do charging. A little bit of everything is required. I am in the camp that every single parking lot needs charging infrastructure, because if every lot has charging infrastructure, you'll never find yourself in a place where you need it and don't have it, right? I mean,
Right.
currently, I can't name a highway, exit currently in California where you don't have 4 options for gas stations, let alone
Right.
one. So I very much feel that something similar is going to happen for EVs, especially as the charge times decrease from a 40-minute average session down to 20 or 15, or who knows, depending on the state of batteries in solid state, it could be down to a 10-minute charging session with just enough time for you to, stretch your legs, use the bathroom, and then your car's done. So I think, the trend we're seeing right now is that it's shifting away a little bit from, large charge point operators just deploying in random empty parking lots, and instead moving to what we call a destination charging model, meaning looking at, streetlight data, looking at telematics, looking at all the information you've got to figure out where are these cars registered and where do they typically go every day, and try and capture that business somewhere in the middle, right? That's the most intelligent way to go about this, or capture them at their end resort or end destination, excuse me, where it'll be a little bit easier to have that vehicle charging on AC or level 2, right? There is an extremely important use case in this industry for level 2 charging. XCharge supports all forms of EV charging initiatives, and even if we don't sell L2 here in the United States, we got our start on AC globally, so we understand how important it can be. But I think that right now, the most important thing to help adoption would be providing DC fast charging, not only so that people can use it all the time, but just so that it provides the peace of mind that gives consumers the amount of confidence they need to go out and spend 30, 40, $50,000 on these vehicles, and not in the back of their mind be worrying about range anxiety, which is currently what's going on.
Yeah, I'd like to jump in with another tidbit there. On the what we're definitely seeing, there's a lot of signals being generated. We're seeing a lot of these signals being created, and they're created from the organizations. A lot of these could be on the public side, like government organizations, institutions, are directly supporting the adoption of infrastructure and vehicles. So you'll see in almost every state some type of EV program or programs, and that could be a combination of a rebate for buying a home charger, a small rebate for a vehicle, of course, there's a federal rebates and tax credits available, a variety of special rate plans to support or to lower the cost of charging a vehicle at home or your business. You'll see a variety of RFPs on a quarterly basis created by utility companies, governments, municipal organizations, et cetera, to support the build out of this infrastructure and or the adoption of these kinds of vehicles or electrifying your fleet. So you're seeing a lot of these things happening. So the dollars are there. And now they're being partitioned, divided up, measured how they're used properly. And then the consumers or buyers are starting to take advantage of these. That's just starting to take off. So really excited to see, these public dollars becoming used and designed and put into subsidies in a useful way. So I think over the next couple of years, we're going to see these different kinds of programs be much more organized. We're going to go through versions of these, iterations of these, and we're going to see a pretty big consolidation as well on the business side. But that's another topic for another day. I know we're about out of time. But yeah, I think on the public benefit, the dollars are here now. Let's take advantage of them over the next couple of years to really help with that adoption. It takes some of the pain out of making those transitions as an individual. So they're there. Let's use them wisely.
Yeah, that's a great call, and that's interesting because we've had a couple other guests on that we kind of get into the incentive discussion, and we had Lauren McDonald from EV Adoption. He was talking about especially around kind of NEVI funding and the pros and cons of it, where he thinks in some ways it's kind of slowed down the rollout of DC fast charging to some extent because so many of these entities are kind of waiting for the money to try and get the site approved, which makes sense. I mean, if you can save some money on a very expensive installation, it'd be a hard argument not to. But I was just curious if you've been working with any, whether large scale or even just kind of smaller operators that have been looking at trying to get approval to use your hardware for NEVI funds, if there's been any kind of interesting insights that your team has had.
We definitely have. And the good thing is that XCharge currently has a NEVI product that's compliant in the C6 that is currently waiver compliant and then will be fully compliant by the end of Q2 of this upcoming year for any future NEVI rollouts. I think Lauren is an extremely sharp guy. I
Yeah.
follow him on LinkedIn, and a lot of the things that he talks about, I couldn't like it more than once, right? Like if I could, I would. And I think he's dead on the money when we talk about some of these incentive programs doing more harm than good for the immediate adoption of electric vehicles now. Because at the beginning of this show, we talked a little bit about how most of the operators in the space are focused on ROI. There are some exceptions to that. There are the EVgo's, the Electrify Americas, the Teslas of the world. And no
Mhm.
surprise, those are the dominant networks in the country today, right? But everybody else is looking at it like a traditional investor. I don't think
Right.
people truly understand how little money that the oil and gas companies make on oil and gas, right? It's the Twinkies and Coke model that we
Yeah.
use. That's what they want to sell. They want to sell convenience inside the store more than they do gallons of gasoline. And I think that there are other ways to monetize EV charging at this moment. And looking at it on a 3 or 4 year ROI is not the best way to do it. But government funding instantly gets you back in that territory where you can get your money back in 2 or 3 years, and that distracts a whole lot of people, a whole lot of sharp people with really talented ideas, with really good properties. And what's really, unfortunate is, I've worked with a lot of our customers and a lot of people that have submitted some dynamite properties in some great locations, saying, oh, I've got 15 of what are going to be ideal EV charging sites that they submit in Ohio, for example, and then they win zero. And that's really
Right.
disheartening. And it almost convinces this operator to just kind of leave the state of Ohio alone because EV adoption is too low. Whereas if it was more transparent how to win this funding, if it was more widely available instead of giving all of it to 1 or 2 or 3 entities, or in some cases giving the money to the utility companies directly, that sort of thing almost disincentivizes private investment in the space, which only drives us away from everybody's mutual goal of as much charging as humanly possible everywhere, which helps adoption. But when you put these extremely competitive federal programs in place and then you limit the amount of people that can actually win these dollars, everybody's kind of waiting and trying to see, is it even possible? Is this a good idea, or should I just not bother? And that's unfortunate for the industry. But I do think that, like Andrew talked about, over time, these entities will get more intelligent about the way they distribute the funds. And then the companies that are looking to use them will be more intelligent about where it does and doesn't make sense. If you've got a great charging location, government funding or not, you should be building chargers on that location. And, and I'll just quickly plug us and say, if you have a good location and don't have the funds for it, call me. We'll figure that part out.
Yep. I will absolutely echo exactly what Lou said. Those entities will become smarter. We will always do our everything we can to inform, government institutions, et cetera, about how to design their programs a little better. So it gets more effective. They're measured on how well those programs are used. If they're not used well, they're going to discontinue a
Yeah.
rebate or an incentive and move on to something else. So we do regularly work with different lobbying groups, different industry and trade groups to try to share our recommendations, our customer feedback, market feedback. Um, but regardless of what happens, let's say at the federal or state or local level on the subsidy side, there's no reason to delay a project in hopes of getting a small incentive. There's a variety of other revenue streams outside of just the charging revenue, which could still be astronomical. Outside of that revenue, there's a variety of other revenue streams on site and in regionally if we want to get into, say, energy trading. There's a variety of revenue streams we can tap you into today rather than waiting a few years, rather than waiting a few years for that expensive infrastructure upgrade you were hoping for. We can get you started early on, and we can work with you on a holistic, 10-year strategy if you want to design something now, planned for some expansions or changes in the future. We're here. We're not just a hardware provider. We want to be an actual partner with our customers going forward, and that's the way we look at things.
Well
No, and
said.
I think that's kind of really well encapsulates the state of where those things are and what your team can do for it. I realize we are kind of getting to the end of the hour or so. So I am curious. Something I ask all of the guests that come on here is if there's any innovative ways that they see that either public industry or government or maybe a hybrid of both can accelerate the rollout of kind of EV and EV charging technology, what you think that would look like?
Oh, Chase, that's a great question. especially coming from my background as an EPC and submitting numerous amounts of applications and then waiting months for the city planner to look at them. I think that there are some states that are better at it than others. California, for example, has an assembly bill that puts effectively a shot clock on all applications from a zoning and permitting perspective that says, hey, if we receive your application and it isn't, either denied or have comments on it inside of 30 days, it's automatically deemed approved. That's a godsend. That's wonderful, right? 4 weeks, even though it's crazy that it may take 4 weeks to look at a one-line diagram and a couple of stalls in a parking lot of an existing infrastructure build, I can live with 4 weeks. What I can't live with is some of the timelines we get in some parts of the world, which are, between 12 and 16 and 24 weeks. Or even, if the government really wanted to speed this process up, rather than, blindly firing cash into the industry, why not work more closely with, the transformer companies, right? And the utilities directly to bring down these 60-week lead times on 2,500 kVA transformers, which again, these are going to have to be everywhere. We know that. It's not a, oh, can we get this stuff installed and wait for a transformer later? What's the point in doing that? I mean, how far could several $billion go for the sheet metal and transportation industry surrounding, the components that make up these transformers and switchgear, for example? Those are the two longest lead times we currently have in the industry outside of permitting. So if I could submit an application, which we currently do for some of our projects, let's use San Diego as an example. Every project that we have signed up in the last 3 months in San Diego won't get built till 2025. That is through no fault of our own. We can't get power from the utility. They don't have the transformers and the switchgear. So all we can do is kind of sit and wait and hope, and I think that's the portion that if I was going to stand on a mountaintop and scream for government intervention, there it is right there.
I would absolutely echo that. If you recall, during the pandemic and right after the world started to open up again, there was a significant constraint on microchips, various kinds of microprocessors. The President Biden, to his credit, took steps to try to work with those different manufacturers globally and creating a plan to allocate, to try to ease some of the challenges in the supply chain. Now, I'm not an expert on how all that went, but we would love to see, we're asking the federal government and the state and local governments certainly to work with them in coordinating something that supports the allocation, the development of these kinds of components, these kinds of resources for our industry. We know that the grid has to go through various upgrades all over the country for lots of reasons, not just for us. So this isn't just this kind of effort, supporting the allocating these kinds of materials, the components that go into transformers and switchgear, isn't just beneficial to EV charging. It's right. beneficial to every single industry in the United States, and we need a robust electrical grid. We're working to that's a priority of pretty much, I think, everybody on the political side of the spectrum too. So let's put our money where our mouths are, and let's actually make this happen. Because if we can support that, then we'll all be better off.
Yeah, I don't think I could agree with either of you guys more. That's great call outs. I think a lot of people might be aware of how permitting can slow a lot of these projects down, but then there is still a large part of that is the supply chain and the utilities for getting those things in place that can then delay it even another year. So totally appreciate your time, both of you today. I just want to say thank you again, Andrew and Lou, for both joining today and kind of having both of you on to explain what XCharge is doing in the space and how you guys are making a difference. And this has been super fascinating and really great to hear, not just what XCharge is doing, but also just what both of you are seeing in the space and kind of insights that you've shared with us today. So thank you both.
Absolutely, Chase. It's been a pleasure. We very much appreciate the invite and letting us ramble a little bit about some of the stuff that we're involved in every single day. So it's been a breath of fresh air to talk to somebody who truly does understand.
Well, my pleasure, and we'll have to have you both on again soon. Talk later.
Well, certainly. Thank you.
Thank you very much. Have a great day.